Hello. Good afternoon, good morning, good evening, wherever you are in the world. Welcome to session one of the seminar about water security within just planetary boundaries. I'd like to give credit first to Juisa Dutra, who's part of the scientific programming committee with me, and Nof Afghani, who is a young SPC member. The three of us were responsible of bringing an amazing group of partners together, partners from the Organization for Economic Cooperation and Development, OECD, the World Meteorological Organization, WMO, the Earth Commission, and of course, Stockholm International Water Institute, SIWI. Water security within just planetary boundaries. We know we are living in the Anthropocene, a time where humans are the dominant force of change on the planet, and not for the good of that planet, nor for the good of the health and safety and security of people and our economies. Our actions push us closer to negative tipping points, and we face these negative tipping points already, putting the most vulnerable environments as well as communities at risk first. The recently launched Earth System Boundaries, identified by the Earth Commission, are scientifically defined safe and just limits for climate, freshwater, biodiversity, nutrient cycles, and aerosol pollutants. By operating within these limits, I just want to emphasize that word, we can maintain a stable and resilient planet and ensure access for everyone to resources necessary for a dignified life. But we know we already crossed those boundaries, and stabilizing, for one, the hydrological cycle, but these planetary boundaries should be front and center for everyone across the world. Session one is about living with the safe and just water boundaries, aimed at a diversity of actors and stakeholders, including practitioners, policymakers, and researchers. Session one will provide the audience with a clear understanding that the global water systems are crucial for the well-being of people and the planet, and that we must stay within safe and just boundaries for blue and green water. And I'll give the floor happily to Albert Nordström from the Earth Commission, who will lead the session, who was responsible for bringing this amazing group together. Albert, the floor is yours.
Thanks, Henk. This is a fantastic opportunity time. It's also a vindication of technology. Some of us are sitting in the same room. A lot of you are all over the world listening in, and hopefully what will be an hour of some fascinating talks. We'll jump right in. It won't spend too much time setting the scene. Henk has already done that. The focus of this hour is about living within the safe and just water boundaries. Quickly, a bit about myself. My name is Albert Nordström, and I'm the Science Director of the Earth Commission. And with us today, we have three fantastic speakers. In order of which they will be talking, we have Ben Stewart-Coster, who is with us virtually from the Australian Rivers Institute, Griffith University in Australia. He's a senior research fellow there, has been heavily involved with the Earth Commission in its first phase and now into its second phase. We have Professor Taikan Oki from the University of Tokyo, who needs no introduction to all of you, who is now also part of the Earth Commission and stepping in as a commissioner in this second phase. And then we're also extremely happy to have Lan Wang Erlandsson from the Stockholm Resilience Center at the Stockholm University. She's a researcher and theme leader there and has been heavily involved in a very connected project to the Earth Commission, the Planetary Boundaries Research Framework. So without further ado, I'll pass it over to Ben, who will begin speaking for 10 minutes. And before we do that, I just want to remind you that there is possibility for questions. We won't open it up for audio, but we will allow you to ask questions through the chat. So if you do have questions to our speakers, formulate them in the chat, and I'll pick up some of them towards the end of the session and choose a few that I will ask. I also have a few pre-prepared questions that we'll ask in a panel-style talk after the discussions. So that's it. Ben, over to you.
Thanks very much, Albert. And thanks very much, everyone, for the opportunity to talk to you from all the way over in Australia here. So yeah, I'm going to give a bit of a whirlwind tour of the Earth system, the safe and just Earth system boundaries, the framework in general, and then the blue water, the boundaries for blue water, and then look at an analysis we did is to answer the question of whether we can live within the safe and just blue water boundaries and provide everybody's minimum access needs. And then if not, what type of transformations do we need to take? So just as a by way of introduction to those of you unfamiliar, the safe and just Earth system boundaries describe a state of the Earth system that can ensure both a stable planet and justice for all people, they were defined to consider local and regional scales, not just the global scale. And we work quite closely with the Science Based Targets Network within the Global Commons Alliance. So the boundaries themselves were designed for translation to local science-based targets. And then finally, a big part of that, as I mentioned in the introduction there, is that we look at the different levers of transformation to identify how we need to transform the way we go about our food production and running our economies to identify ways we can potentially move within the safe and just corridor. So I'll go to the next slide. Thank you, Jason. So setting just boundaries is a difficult exercise. I'm a freshwater ecologist, so I'm a biophysical scientist. But the just boundaries, the driving principle to define the just boundaries was that they aim to minimize significant harm to humans from Earth system change. So they're very much about protecting people from the damaging effects of Earth system change that come from the way we alter the Earth system. And as such, they may actually be more stringent. They may be more difficult to meet than what we would think of as safe Earth system boundaries, because people get harmed before the Earth system starts to show dramatic changes. So I'll just move to the next slide. So when we were developing the blue water Earth system boundaries, we really sought to put the focus primarily on primarily in the field of ecology and flow ecology relationships. So whenever we alter surface flows or groundwater flows necessarily to provide water for agriculture and industry, that negatively impacts aquatic ecosystems and the ecosystems they provide. A recent example of a review an important illustration of that was some work that showed that 77% of the world's marine fishery catch comes from species reliant on river flows at some stage of their life cycle. So an enormous amount of food and critical protein needs for people the world over relies on freshwater ecosystems. And we know that as we alter those the surface flows and the groundwater contribution to those surface flows, those things like fishery catch become negatively impacted. And so we used this local scale grounding in flow ecology research to inform that. We'll just move to the next slide. So the local scale flow ecology research is usually used to determine a safe level of flow alteration, but to balance between competing needs for blue water. And that can provide the basis for local scale safe boundaries, and we argue that it should. But in the absence of that kind of research for the majority of the world over, we used presumptive standards. Essentially, it's a case of the relationship between aquatic ecosystems and river flow and aquatic ecosystems and groundwater are so incredibly complicated, needed to default to a relatively simplistic measure for the Earth system boundaries. So for surface water, we used a presumptive standard from the flow ecology world that if we maintain river flow within 20% of the natural flow regime, then that generally keeps aquatic ecosystems safe. And similarly with the groundwater, if we ensure that the annual drawdown from natural and anthropogenic factors, natural discharge and anthropogenic extraction, if that annual drawdown stays within the average annual recharge, we won't see this declining groundwater trend that you can see on the bottom right there, which is some recent data from the GRACE satellite. So we define those local Earth system boundaries that could be applied in a catchment by catchment basis on aquifer level, and then we determined that there's really no just way to declare which river basin could be outside a boundary of safety. So we determined that 100% of the land area should meet these local safe and just boundaries, to be considered globally safe and just. So just go to the next slide. And then while we defined those boundaries, that was one thing, and we quantified the extent of the Earth system outside the boundaries. We then wanted to look at, well, if can we actually meet them? Can we meet all of people's minimum access needs, and not just water for domestic use, but water required for infrastructure, water required for food production, across all of these necessary needs that we have. We looked at a scenario where all people have equal access to water. So not a world where we overconsume in the West and some people underconsume in the lower income countries, but what about the world where we all have minimum equal access to this minimum level of water? And we answered a series of questions through that process spatially to identify where we can meet these Earth system boundaries and provide minimum needs, and where we need to change the way we produce our food and so on. So we just jump to the next slide. What we found was that, in fact, we need to do a lot of transforming, which I'm sure doesn't come as much of a surprise, but we identified the different types of transformations on a catchment by catchment basis around the world. And we found 2.6 billion people live in catchments where there are insufficient surface water flows to meet basic needs while meeting the Earth system boundaries. So we need to look at supply side transformations. 1.4 billion people live in catchments where we need to look at demand side transformations because they're already outside the Earth system boundary, or there's insufficient water in those catchments to meet their needs. And then we found a further 1.5 billion requiring both supply and demand side. That doesn't add up to the 9 billion people on 8 billion people on Earth, and the balance of the world live in catchments where we could actually meet our basic needs, and we are underneath the Earth system boundary already. So we'll just jump to the next slide. So I mentioned earlier that part of the focus of this work was to identify levers of transformation where we can, of how we can change the way we do business, how we produce our food, how we go about running our economies. And we know there are lots of pragmatic different ways we can, improve our water use efficiency, reduce water consumption. But part of this work was to identify where we need to apply these supply side versus demand side transformations. And these might be things like shifting between groundwater and surface water where that's feasible and sustainable. A transition to more green water agriculture if we're talking about catchments where green water is more abundant. And things like improving efficiency of water use, but that needs to be coincide with just regulatory environments to ensure that any efficiency gains are not just siphoned off to the highest bidder. So there's a whole range of things. And then I did want to touch on those indirect transformations where we're really starting to see the interaction of different Earth system domains, and things like restoration of catchment vegetation, which is going to improve green water retention. It's going to improve water quality, runoff, and things like that. So we really need to think about these systems holistically. And so the next stage, the final point I'd make before handing back to Albert was, as I said at the very beginning, the Earth system boundaries had a real focus on coming up with, working from a point of view of translation. And translation means taking these global scale boundaries and converting them into local scale targets for companies, cities, and other actors. And so that we use that requirement or that goal, I should say, to inspire the way we develop the boundaries, and we collaborate with the Science Based Targets Network along that line. But this is just some work from the Earth Commission where we showed essentially a conceptual model of the process of transcribing these global scale Earth system boundaries into local scale pressures or local scale budgets, which we could think of quite clearly with water, and then identifying just allocation of resources and just allocation of responsibility for changing the way we use our water. And that allows companies to then identify their appropriate shares of water, or cities, appropriate shares of water use and responsibility to identify specific targets, which can then be implemented to reduce water use or make it more efficient and so on. So I think that's about all I have. Thanks very much, Teresa, and thanks everyone for your time. I look forward to chatting soon.
Thanks, Ben. And thanks for keeping time so fantastically well on the spot, on the second. I'll save. I have some questions. I'd like to pick your brain a bit, Ben, but I'll save them, and I'll move straight over to asking Taikan to go with his talk.
Okay, thank you, Albert. And good morning or the good afternoon or wherever you are. This is Taikan Noki, and I talk about that the climatic risk boundaries. You may be confused, but I believe that this concept can help think about that the Earth system boundary for the climate. And next slide, please. You may know about that the human ecological niche, that the what kind of the mean temperature and the precipitation we have been or that human beings has been living. But this diagram is about extremes of the temperature on the horizontal axis and precipitation in the vertical axis, and once in 20 years of the extreme high temperature and extreme daily precipitation. And thick and thin color indicate that the population, how many population in the past or that in the 20th century. And you see that, for example, temperature, that the extreme once in 20 years temperature, high temperature of that around 40 Celsius degree and 100 meter a day of that the once in 20-year precipitation, we were exposed in the 20th century. But if that the climate change will be extreme, next slide, please. Yes. So that the temperature and climatic risk will shift to the higher temperature and somehow that higher precipitation extremes. And please, next slide, please. Yes. So that if we think that the boundary of the 20th century to be that global climatic risk boundary for the 20th century, that that the a little bit of the right-hand side part, that at the end of the 21st century, some people will be exposed to the unprecedented extreme climatic risks, which nobody has exposed in the 20th century. Then how can we adapt to such an new risk or that much harder risk of the higher temperature and higher precipitation? And let's see that where these people are located. Next slide, please. Yes, so that the yellowish color indicate that the people that the mainly exposed to that the unprecedented extreme high temperature, and these regions are located in the Sahara Desert and Arabian Peninsula, but some part of the Pakistan and West Asia. But you see that some Australian and also that the Western US. And bluish color indicate that the unprecedented extreme precipitation risk at the end of the 21st century. And that's widespread from that the southern part of US and some part of South America and middle of the Africa and Madagascar and western coast of India and Bangladesh and Southeast Asia and the southeastern part of China and also that the southern part of Japan and Korea. And both the reddish color indicate that both temperature and precipitation, that the unprecedented risk that people will be exposed, that mainly distributed in the Ganga River Basin in India. And that number account to the 2.5 billion of world population if that climate change will be more than 4 Celsius degree. Even we can keep the temperature rise to the 2 Celsius degree, but still 1.1 billion people will be under the new climatic risk, which never have been exposed in the 20th century. So next slide, please. And if we pick up that the Southeast Asia, for example, And you see that the outer line is the global climatic risk boundary of the 20th century. And the inner line, that green one, is that current climatic risk boundary in the South Asia, but it will shift to that red dashed line, future climatic risk boundary in the Southeast Asia. So you see that some part like that for example, that the Kuala Lumpur, of course, that the extreme temperature will be higher and also the extreme precipitation will be higher, but that within the same current climatic risk boundary in South Asia now, that means that they can learn how to survive under such an extreme risks. However, for example, that the Vientiane of Laos, that the is out of the climatic risk boundary of the Southeast Asia, South Asia. However, still they can learn from that other part of the world where that it was already exposed to such a higher risk. But I'm sorry that it is not could not be appropriate, but in some part of India that will be out of that current global climatic risk boundary. So how they can adapt to the unprecedented climate risk, that is an issue. Next slide, please. So that what I'd like to share with you is that the limits to adaptation should be carefully examined. So we cannot adapt to all the extreme events anticipated under that higher climate change. And then the smooth exchanges of knowledge and technologies through global partnerships based on multilateralism is critically relevant for the implementing applicable and efficient adaptation measures to climate change. In addition to the sufficient investment, that's what I wanted to share with you. Thank you very much.
Thank you so much, Taikan. I think your talk really highlights the new risk landscape that we're very closely moving into and already entered into in the Anthropocene, but also how we're possibly reaching hard limits to adaptation. A lot of food for thought, and I'd just like to remind folks listening in to please share any questions you might have in the chat. We might not go through all of them, but we hopefully have a few minutes at the end to pick up one or two of those questions that pop into the chat. Lan, I'll pass the floor over to you for the final 10-minute talk before we go into a short Q&A between myself and the three of you.
Thank you so much, Albert. It's a pleasure to be here. Hello, everyone. In my talk, I would like to direct our attention to green water changes that are now so severe and widespread that they threaten Earth's resilience. So in the Ben's and Taikan's talk, we heard about the exposure of population to water changes risk. In my talk, I was focusing on the Earth's resilience, so the threats to the habitable conditions that we know for sure are able to support humanity to develop and thrive. So not directly population impacts, but the threats to the habitable conditions. The term green water was coined by the late Professor Marlin Falkenmark to make a distinction between blue water on the one hand, so the water in rivers, aquifers, and lakes, and the green water on the other hand, that is the soil moisture that supports terrestrial ecosystems and croplands. She made this distinction because most of the water resources decades ago and still focus most of its attention and investments in the blue water sources and tended to forget about the vast green water resources that also need to be managed. Still, over 90% of the agriculture in sub-Saharan Africa and South America are rain-fed, and as we shall see later, green water also has essential functions for our climate and terrestrial ecosystems. Next, please. Yeah, so that's the blue water and green water. Together, the green and blue water, they serve to, please click the animations. So together, the surface and groundwater and frozen water will regulate the sea level, and rivers are also important for nutrient and carbon transport. Surface water, and they are in themselves supporting aquatic habitats, and the green water are important for upholding terrestrial ecosystem. Click, please. Particularly the green water, soil moisture and atmospheric water are important for the climate, because the terrestrial systems, as we know, they uptake around a fourth to a third of all anthropogenic carbon emissions annually. So the water availability for terrestrial systems directly affect how much carbon emitted to the atmosphere and the climate we get. They also regulate the cloud formation and therefore the radiation balance of the Earth. Regionally, we know that evaporation fluxes are directly linked to regional weather systems, such as a monsoon. So, for example, in India, we know that the irrigation has now been so impactful that they are affecting the onset of the monsoon. Next, please. Yes, please click on. However, we now see that the green water changes are unprecedented, at least for hundreds of years and even thousands. So they're becoming both wetter and drier than conditions known to modern human civilizations. Next, please. And wet departures are primarily seen in the higher latitudes, and whereas dry departures we see across the tropics as well as subtropics with some exceptions. Click, please. These changes are driven by greenhouse gas emissions regulated by aerosol loading, as well as deforestation and land degradation. And in India particularly, but also in US and elsewhere, large-scale irrigation is also a key driver of these changes in water, in soil moisture. Next, please. These departures are not just some abstract numbers that we can chunk and see in our data, but they in fact manifest themselves as highly concrete and noticeable changes. So for example, here we see the Canadian Arctic region with the abrupt permafrost thaw. In Cerrado, please, click please, yes, we're also in Bangladesh, we have waterlogging issues. In Cerrado, in many savanna regions, we have drought and fire and so forth. Many of these changes are non-linear and they're non-local. They cascade and they spread. So for example, as we see here in the tropical forest, as precipitation decrease, there is a risk that the system abruptly collapse into a savanna-like state, and to bring it back to a forest state, you would need a much higher level of precipitation. This is because one of the reasons this is because once a forest is logged, click please, the rainfall is reduced because the forest is producing part of its rainfall itself. So the rainfall as forest is lost is reduced locally and regionally, leading to further losses in tree cover, which amplify the effect of deforestation or forest loss. This is an amplifying effect at a regional scale. At the global scale, we also have such amplifying effects. So for example, we have evidence now suggesting that the carbon sink strands across the tropics have peaked. And particularly severe is the situation in Amazon, where it's an anticipation if the trend continues that we will have the Amazon forest switch from a carbon sink, a net carbon sink, to a net carbon source. So instead of helping us to uptake our carbon, it's emitting carbon, which then aggravate climate change and further drive the hydroclimatic shifts that reduces the carbon sink strength in the first place. So this is an amplifying feedback at the global scale. Next, please. There are also stabilizing feedbacks. So for example, as we have higher CO2 concentration in the atmosphere, ecosystems and terrestrial systems are also able to use to have a more efficient photosynthesis. So you need less water to grow biomass. This could be seen as a stabilizing feedback. But recent studies now suggest that this greening trend might not be able to continue because of soil moisture drought. Next, please. So there are major question marks whether this greening trend will be able to continue because of soil moisture limitations. Next, please. So overall, we see many kinds of amplifying feedbacks across many different types of biomes in forests, in peatlands, in drylands, and permafrost. We do have some stabilizing feedback that there are signs that they are now weakening. So overall, we concluded that these are signs that the Earth's capacity to deal with water perturbations and to remain functional are diminishing, and green water changes are now seen to threaten Earth's resilience. Next, please. The planetary boundaries has been fully assessed, comprehensively assessed 3 times in 2009 when it was first introduced, in 2015, and now again last year, 2023. And in the last year's assessment, freshwater change was assessed to be transgressed, both for blue water change, but also the green water change, due to these observations of widespread variability changes in green water, as well as evidence of non-linear system risks. Next, please. So to sum up, we concluded in our research that green water is now outside the planetary safe zone due to that the changes in green water are now depart from conditions known to support human civilizations. And these changes are now triggering non-linear system feedbacks. And so to turn the tide, we now urgently need to address the drivers of green water change that include halting greenhouse gas emissions, avoiding deforestation, land and soil degradation, and to revitalize ecosystems, and particularly their eco-hydrological functioning, and to support sustainable agriculture. It's easy to feel overwhelmed, so I just want to end on a positive note. Next, please. So for context as well, I wanted to say that we could also have been in a worse place. Next, please. The climate policies have made a difference, and more is needed, obviously, but the current policies have already avoided the worst climate scenarios. And the same in Brazilian forests. We do have a lot of deforestation, but we have also seen that forest policy can make a huge difference, as we've seen in the declining deforestation rates during Lula rules. So the hope is not out. We just got lots of work to do. Thank you.
Thank you, Lan, also for really highlighting these really critical nonlinear dynamics involved in the big global water system, and highlighting the both stabilizing and amplifying feedbacks, which I think is a fascinating way to possibly underpin some of the monitoring capacities of understanding how the system goes. Speaking about monitoring, I'll start with you first. I have a question, Lan. Tomorrow, this seminar series continues with a session that will be partially tackling the role of technology innovation in water monitoring and how that can enable just water security. Could you share some of your insights on some of the opportunities, but also challenges for global to regional monitoring of human-driven green water modifications, and how this can contribute us to avoid crossing these big irreversible planetary scale tipping points that you speak of?
Sure. Yeah, so there is definitely more and more data out there, especially satellite-based data. For example, we see that they are now existing at increasingly higher temporal and spatial resolution. So we know what is going on. There's also more advanced methodology now to be able to detect early warning signals if there is a tipping risk, for example. However, there is question mark because these changes, these amplifying feedback that we see, they come at the long term. The drivers, it's not as if we see that there's a tipping risk and we can just sort of halt the system. The train is hard to stop. So the important here, I would say, that is to monitor not only the changes that is going on in green water, but also the drivers, and link the changes in the drivers and particularly to the actors that can do something about these changes, to the changes that we see in the ecosystems. So, for example, we still lack a lot of in situ observation and data in many of these major tipping points in the Earth system. In Africa, it's just only a few years ago that this vast wetland was discovered in the middle of Congo that contains lots of peatlands and lots of methane emissions that we just starting to learn about. And also in South America, there is still a paucity of record to help us better understand the dynamics in the system. And then to link that to the actors, we still have lack of company disclosure, for example. So you're able to link the responsibility of particular actors to what is going on in the Earth system. I don't know if that was helpful.
That was very helpful, Lan. Thanks. It's a very concise and focused answer to a very broad and possibly complex question. My next question, I have Taikan in the same room with me, so I don't know if I should be looking at the screen or at him. But thanks, Taikan. Your talk was really fascinating. But at the end, you mentioned multilateralism and the importance of exchanging knowledge, information, technology across borders as a key ingredient for really trying to push the borders of adaptation, right? Which you spoke about. We're hitting those limits of adaptation. I think it'd be really interesting for you and your experience working across the world. Do you have any really good examples of some of these bright spots or seeds of hope of where that kind of multilateralism and exchange is really happening in ways that is really pushing the limits of adaptation and expanding them?
Yeah, I think, of course, that the symbol of the multilateralism in that climate change adaptation could be that the working group 2 of IPCC, where that, so many good practices and exercise are categorized in like a catalog of the good practices in it. However, not so many people will read in details about this big IPCC report. And I had critics or the complaints from my colleague that there is a gap between that IPCC reports and UNFCCC process. Even though that there is a good practices listed in the reports, but that is not implemented in reality. So we have to fill the gap between that what known versus that really implemented by each government or the local government or the local communities. And in Japan, that the Ministry of Environment is now developing platform to collect that the good exercise of practices of the adaptation together with that knowledge about the future, what will be the future climate change, and hopefully with some risks in each region, which risk you have to pay attention to, and what could be the possible adaptation options you can think about. But of course, that the applicability of the adaptation rely on that cultural, environmental, and maybe social conditions. But still, that I think that kind of the catalog could work, and to develop such a system under the multilateralism will work, I hope. Thank you.
Thanks, Taikan. Yeah, I think this idea of having catalogs or repositories of seeds or bright spots is good, but that requires working closely with the people that can actually use them to make change on the ground. No, thanks for that. Yeah, Ben, over to you. I mean, I've seen there's a lot of questions in the chat actually that sort of pick up on the theme of the question I'm going to ask you. It sort of links with some of the applicability and the translation of the work that the Earth Commission is doing into targets. And you mentioned that you, with many of the other folks within the Commission, have been working closely with the Science Based Targets Network, the SBTN, which is an initiative grounded in the best available science and trying to outline what businesses and cities must do to stay within Earth's limits while addressing human needs. Could you share some short reflections on how the work of the Earth Commission or any other type of similar initiative and SBTN can then contribute to sustainable management of water at a basin level?
Yeah, thanks, Albert. I mean, it seems a simple question, but I think it's in some ways a little bit complicated. But I think one of the thing that I'm most sort of inspired by from the Earth Commission framework in this context was the really strong theoretical grounding in justice that the Earth Commission had. So there's an entire framework on Earth system justice, and that feeds into the translation framework that I talked about. And so the SBTN is working actively with companies to design approaches to set targets for companies to set targets. And I think that is a really critical way that this can happen, in the sense that setting targets is something we've been doing for a long time, but setting targets with a concept of justice embedded in them. And so that it's not just a just allocation of resources, as I said before, but a just allocation of responsibility for the existing Earth system change that we've seen, and the responsibility to make the changes that need to be made to come within those, to bring ourselves within the boundaries. So I think that's a really, to me, that's quite an important advance. The other thing I would say, and I'm just seeing some of the questions there in the chat as well. I don't think I can answer all of them in this particular moment, but we'll see how I go. But I think one of the things that I would say is that in terms of dealing with these targets at a catchment scale, we really need to start thinking beyond water alone and start thinking of the whole of the aquatic ecosystem. So improving our water use or our water allocation comes from things like reducing our water consumption and reducing our water withdrawals and designing environmental flows to support aquatic ecosystem services. But it also comes from the other components of the Earth system domains that are included in the Earth system boundaries, being things like restoring the riparian vegetation on stream banks and around wetlands, for the purpose of improving water quality and the purpose of increasing green water availability and slowing the flow of water to the river channels and things like that. So I think in terms of identifying targets, we need to think beyond just water and think of the whole of the whole of the aquatic ecosystem. And that kind of thinking will also help strengthen the resilience of aquatic ecosystems to the impacts of climate change that we know are coming, that Taikan alluded to so clearly, and Lan as well. So I think that's sort of a really big, a key takeaway for me, is that just allocation and thinking far more holistically when we're managing water and managing our impacts in certain catchments.
Thanks, Ben. So I'll just get back to I'll get to the questions in the chat soon. So just keep on going. I see a lot of them are popping in. Really, really interesting stuff. But I have just a sort of a broad question to all three speakers, and I'll leave it to you as to who wants to have a stab. All of you in different ways have been working in this space for a very long time, and you must have kind of been reflecting on, some of the key challenges in really integrating social justice into water policy, especially in many of the regions where marginalized communities have historically really limited access to clean and safe water. So again, you've touched upon some of these aspects, but how would you say some of those challenges, like first, which ones are the biggest ones? And then how can those challenges be addressed through different ways, like, for example, international cooperation or local governance? And maybe Taikan, you're sitting opposite me here. Maybe it's unfair to start with you, but any short reflections on that?
Well, I think that the key issue is that sometimes people think that ordinary people think that the no access to safe drinking water is due to that dry environment, but that is not true. Even in Japan, without that right facility and right management of the water infrastructure, there was so many, droughts and water supply stopped in the past. But by developing that infrastructures and managing them in a sound way, now we can have somehow stable water supply. So that we should think about that the water supply is not the, environmental concern, but that is a development issue. And for that, we need a proper investment and proper management of the water facilities. I think that we need to change that, perception of the ordinary people that, oh, the Africa is dry, or the Southern Asia is very hot, therefore they do not have water. That is not right. I think that kind of the change of our mind is necessary.
Thank you very much, Taikan. I'll pass that question over to Ben, and I'll leave Lan as the last speaker to reflect on that. So Ben, your reflections on that question.
Yeah, it's a tricky one for me to reflect on, actually, Albert, as I sort of want to shy away from it and put on my hat as a biophysical scientist. But I have been observing the deliberations around justice in the last few years, and I do think the a really key thing that I've noticed in discussions has been the signing away of rights to water in some of these, whether they're subnational or international agreements, selling water to private interests at the expense of local users who may be disempowered from that decision-making process. I don't know the best way to resolve those sorts of issues, but that's something I see. I actually do a fair bit of work on the Mekong Delta with rice farmers down the Mekong Delta, and looking to manage something similar to what Taikan was talking about, looking to manage an abundance of water, but the water's too salty at the wrong times of the year. And the farmers on the Mekong Delta are at the bottom end of a very, very complex river catchment with multiple uses. I just don't know how to solve that problem, but I think, yeah, I don't actually have a decent answer, because it just seems such an impossible problem for me to solve. But it's certainly something that we really must do. Yeah.
An intractable, wicked problem in many ways, right? Lan, any reflections as well on that, on what's been said by Taikan and Ben, or your own reflections as well on the question?
Yeah, so maybe if I am allowed to tweak the question a little bit, especially since I've been talking about the Earth system impacts and long-term impacts, a justice perspective is, as Ben introduced before, the intergenerational perspective. So the social justice is not only about the spatial injustice, but also intergenerational. So here I think that the international collaboration and sort of bringing in the perspective of the future vulnerable social groups are also really important, as we now see in sort of youth litigation, climate litigation issues. We are also sort of moving into a space from, I guess, when we still could talk about win-win, where sort of everything could be good for everyone, to a space where we have to compromise because of ongoing climate change. Is becoming increasingly difficult to achieve every single goal, and there will be a trade-off, and who wins, who loses. And I think that's also where maybe more international collaboration and more discussions across groups, sort of, especially when we took, say, for example, I mentioned most recycling, so where water that provided by forests in one place could travel thousands of kilometers to provide water resources for another place, another country, and how to then balance the trade-off. Maybe the forest is withdrawing water, using more water, and then supplying that to a different region. How are these water redistribution negotiated and talked about? So yeah, they're just like new issues that are going beyond the local communities, but that affect the social justice of the local communities, that just need to come in somewhere in the international regional collaboration. If that makes sense to you.
Thanks a lot, all three of you, for some really, a lot of food for thought, truly. Looking at the time here, I think I'm going to shift my focus to some of the questions that are popping up in the chat. Actually start with I think it was the first one that was said here. It has some thumbs up. I'll try and broaden it a bit. The question was formulated on how, big global Earth system models of the types that have been discussed here can be applied to more local, regional landscape scales in ways that can capture the concerns of communities, the dynamics, the specific contexts happening there. I think this is something we all try to strive, whether it's how to kind of downscale models, it's how about we can downscale frameworks. I think all of us working in the sustainability science space are trying to face with those challenges. So do you have any reflections from your own work on how you have been or would like to be using some of the models with local communities to capture local contexts? I'll just let you raise your hands, whoever wants to have a first stab at that, Tyke, Ben, and Lan.
Well, what I can tell you is that the global of these models, now their accuracies are improving, so that with some modifications or that focusing on the specific region, if you have a very nice regional or local optimist model, you should use that outputs. But sometimes now that the local or regional information not enough, but still the global ones can tell you that may not be that exactly that the real situation, but proxy of that, what you can tell and what you can rely on can be estimated using global Earth set model. So I think that even now, I think that it's worthy to trying to apply that output from the global optimist model to the regional issue solving or the planning how to tackle with the issues. Thank you.
Thanks, Taikan. Ben and Lan, do you want to add anything to that? Ben,
Do you want to go ahead?
I see you already say
okay, I'll
something.
go ahead.
Go ahead.
Yeah, sure. Yeah. So I mean, I think this is a great question, and I mean, I agree with Tarkan. My experience in freshwater ecology and in environmental flow management is far more local scale, and my view is we need to use the global scale Earth system models to sort of identify hotspots and areas where we may need to put really targeted focus. And in many areas of the world, local models will exist, and in many areas they won't, and we'll need to rely on those global models. I think a key aspect of that then needs to be just local scale participation. So it's really important, like one of the things part of the Earth system boundaries for blue water in the sort of the subtext is that where we have local scale information and local scale values, we should use that, because that's that we're designing these local scale variables. And so I think that's a really critical thing to include in our use of these global scale models. Is we need to zero in downscale, and then downscale with people in mind, and in engagement of people at that local scale, so that we can sort of try to achieve these outcomes at a scale that is meaningful, and in terms of outcomes that are meaningful to the people who are in a given catchment. And yeah, so I think that's to address that, and I'll stop talking to hand over to Lan.
No, I completely agree. No, I think really our system, so where there is local data, of course, we will try to use that as much as possible, because our system models are really coarse, but they are super helpful for identifying hotspots that are important at the global scale, such as Amazon. We know it's an important carbon source, that is carbon sink at the global scale. And also, if we go beyond Earth system models, there are also global models like integrated assessment models and other more experimental type of models that are, and also more global analysis in general that can help identify drivers, because there are so many teleconnections now from trade, from so many perspectives, that the drivers which I see, they are not local anymore, are globally driven. They're teleconnected with with neighbor regions and so forth. So I think there would be an increased need of models that can account for relationships outside the local basin or local region.
Thanks, Lan. And thanks to all of you. I'm wary of the time. I see there's 3 minutes left, so I think we should we're gonna wrap things up there and not open up to any other more questions because we want to respect the speaker's time and all the audience as well want to move into different sessions. I just want to, end by saying a huge thank you to our three speakers for being here in person, being here virtually. Ben, I know it's very late in the evening for you, based in Australia. Thanks to the audience for checking in. There's actually people moving into the room now for the next session. So again, a big physical virtual round of applause to speakers. But remember that this is just the first part of an ongoing session that will continue tomorrow and on Wednesday, as Henk mentioned. So please stay tuned. This conversation will be happening and continuing. And please, if you're curious as to the work of the Earth Commission, an email to myself or to Ben or Taikan. If you're curious about the Green Water Planetary Boundaries work, email Lan. And let's keep the conversations and the connections continuously evolving. Thanks, everyone.